I'm Nathan Rose. I'm one of the principals and directors at Kineticorp. We're a forensic engineering firm. We do a lot of different types of cases. Today we're heading out to Los Angeles area. A crash that happened out there that we're working on involved two packs of motorcyclists on a mountain road. And so our role in this case is, one, to reconstruct the accident, figure out what happened. After we determine that, then we'll be looking at the characteristics of the curve. How difficult is the curve in terms of a motorcycle skill level? And we'll be doing that based on physical evidence and based on principles of physics.
So what we're doing here is we're scanning an exemplar motorcycle. This 3D laser scanner will take millions of measurement points to give us the exact geometry of the motorcycle. Now, we scan it from a couple different locations, so we have the point clouds from different vantage points of the motorcycle, and we'll be able to see on a component by component level how this fits into the evidence from the accident. So here I've tapped into the battery of the motorcycle to get a 12-volt power source, which is powering our V-Box. And the V-Box is the brains that's going to tell us the precise location, speed, and lean angle of the motorcycle as we go on our path. I've connected first off the power to the V-Box. Second, I've connected two antennas. These antennas I have mounted on a rig. This rig is perpendicular to the axis of the bike. And these antennas are exactly 1 meter apart. That's important that they're 1 meter because having two antennas is what allows us to measure the lean angle of the bike, and we want to make sure that we have a precise measurement of what exactly that lean angle is. Now, I also have included a trigger. This trigger will let me start and stop recording events. So we're going to use this to do a run through the canyon, and in doing so, we'll know how much lean was required on different turns and at what speed those turns were taken.
I'm looking over our map for our ride today. We're getting the bike equipped right now with our V-Box tracking system, and we're gonna take our ride tracking the path of travel.
So right now we have our primary chase camera on the hood of our vehicle, and I'm setting up a secondary camera that's a little bit lower, and that'll give us a better view of the lean angle of the motorcycle as we progress through the route. We're also going to have a chest camera on William, our rider, and a helmet camera. So we'll have a total of 4 cameras capturing the ride.
So today we'll be documenting the geometric characteristics of the curve. We'll be determining its radius, cross slope, slope. So we'll be able to bring a very quantitative perspective to analysis of these curves. It won't just be based on our judgment, but there will actually be numbers behind it. It'll be based on actual quantitative data, which is really a pretty unusual thing in the industry, specifically for motorcycle crashes, and looking at a more objective way of assessing how challenging or not challenging a curve is for a motorcyclist. How was it?
It's good to be off the bike. It's a stiff position you got to hold for the whole time. We came through all the curves. This is the subject curve. I went through it. I didn't notice it as being the subject curve, but now we're here. We're gonna collect some data.
Right now we're documenting the geometry of the accident site using our 3D laser scanner. And what the device will do is it'll rotate around, shoot a laser out. It'll take millions of individual measurement points where certain points on the road are. And then after it does that, it'll rotate around again. It'll take photographs, and ultimately it can map the colors from those photographs onto the points. So when we view the data, it'll look like the real scene.
unmanned aerial vehicles are useful in accident reconstruction, and we've been working with drones for a little over 2 years now. One of the better uses that I've found is actually a shot from about 400 feet. And so the advantage of that is we get a great view of William as he's riding through the curve. And also because we are documenting the characteristics of this curve, we can analyze the video to figure out what speed he took the curve at. So this is great. I'm up high enough that I can actually get William on the whole curve. It's a curve that traverses a little bit more than 180 degrees. So this is a more challenging curve than the subject curve.
So this curve we're on now is a curve we've identified as being similar, potentially even more challenging for a motorcycle rider than the curve on which this accident occurred. And so we've been doing some drive-throughs with William on the motorcycle. And now I'm in the midst of documenting the characteristics of this curve with our laser scanner. On this one, I'm just going to take one scan to get the cross slope of the curve and the upslope, and then we'll use an aerial photograph to get the radius. So we're heading back to Denver this morning from the Los Angeles area. Collected a lot of great data on this trip. We got video footage of William traveling through various curves that are involved in the route that this accident involves. We've got scan data, V-Box data. We're going to go back to the office and we're going to start processing that data. The thing we found surprising yesterday was that the curve that's involved in this accident, William didn't even notice it. So one of the issues is how difficult was that curve for the rider to handle. And one of the big next steps that we'll be looking at is physical evidence for this case. We'll get all that evidence on the diagram. Could be tire marks, fluid marks, rest positions of the motorcycles and riders. That'll help us determine the speed. And so heading back to Denver to the office to begin looking at all those issues.